Okay, I got an example here of a set theory problem where we're looking at orderings, and this is a problem out of Bender and Williamson's chapter on sets and functions. It's problem 1.5, and I've pasted it in here from their PDF. This is off the Bender and Williamson free textbook online, and so I'll do this as an example. Of course, there's a solution in the back of the book available online, but I'm going to go ahead and do this one. And so it says, let sigma be the set that contain, well, they call it an alphabet here. Sigma, it's not written as a set, it's written as an ordered pair that's an alphabet. And we're going to list each of the following sets of strings over this alphabet in the order indicated. So, they're using slightly different language here than we've used in class. At least I mentioned this language, but I didn't emphasize it a lot. What we're doing is we're making sets of strings over an alphabet, and that means what we're really doing is we're taking that set sigma, and we're talking about the set S, which is made up of sigma, oops, this is a typo, sigma union with sigma squared, union with sigma cubed, union with sigma to the fourth. And so if we're talking about all strings made up of to 4 characters of length 1, 2, 3, or 4, it's sigma, the set sigma, those that are of length 1, sigma squared, those that are of length 2, sigma cross sigma. Don't be worried by the fact that it's a sigma. It's just a character. Sigma cubed is those of length 3, and sigma to the fourth is those of length 4. Okay? And so, part A, let's just get into it here. Part A says all palindromes, that is, strings that read the same forward and backward, of length less than or equal to 4. List them in dictionary order. Well, first of all, I'm going to list them. Palindromes of length less than or equal to 4. Okay. And the elements of the set are X and Y, right? Yeah. Okay, so palindromes of length less than or equal to 4. You know what? I'm going to write out the set S is equal to sigma union sigma squared union sigma cubed union sigma to the fourth. And I know it's going to have 2 plus 4 plus 8 plus 16 elements. It's going to have 24, 28, 30 elements. X, Y, X, 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 Y, Y, X, Y, Y, X, 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 Y, X, Y, X. I'll write most of them out. Y, 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 X, X, Y, X, Y, 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 X, and Y, 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 X, 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 Y, X, X, Y, X. Hope you see the pattern here. It's very much like counting in binary. X, Y, X, Y, X, Y, Y, X, X, Y, Y, Y. And then Y, X, 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 Y, X, X, Y, Y, X, Y, X, X, Y, 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 X, X, Y, Y, X, Y, Y. Oh, why am I writing all these out? Well, what I'm going to do is, it didn't take that long. Do I really have 24, 28, 30 of them? Let's double check. 2, 4, 4 and 4 is 8, 4 and 4 and 4 and 4 is 16. Yes, I've got them all. Now I'm going to go ahead and look for those that are palindromes. That is the same read forward as backwards, okay? X and Y both make the cut. XX and YY make the cut. Triple X, triple Y, quadruple X, quadruple Y. And now if I put a Y in the middle, I'm okay. Or just an X in the middle, I'm okay. They read the same forward as backwards. On the ones that are of length 4, I've got to have the 2 in the middle the same and then the 2 on the outside the same. So x, y, y, x, and y, x, x, y. None of the others read the same forward as backwards. Okay? I hope you can see that. Those are the elements, and we're going to put them into dictionary order here. Okay? So I'm going to go ahead and start with an X section and a Y section. Okay? The X section starts with X, and goes to X, X, then goes to X, 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 and then goes to X, Y, X. How many do I have? Let's count them here. How many green ones do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm hoping that half of them are X's, and half of them begin with X and half begin with Y. Let's count the ones that begin with X. 1, 2, 3, 4, 5, 6. 6 begin with X and 6 begin with Y. Okay. I got 4 of the ones that begin with X. Now I guess I just need the length 4 ones. X, Y, Y, X. Okay, there they are in dictionary order. You can see that any time I start with an X, I finish, oh, just a second here. They're not in dictionary order. If I start with the X's, I stick with the X's. If I start with the double X's, did I stick with the double X's? No, I didn't. I went to an XY before I went back to the double X. I better watch it here. X, 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 Y, then go to the XYs, and I have XYX and XYYX. Now, have I done it properly with the prefixes? Once I start with X's, I stick with them. Once I start with XX, I stick with them before I move to the XYs. Once I start with triple X, I stick and get all the triple X ones. Once I start with the XYX's, I get all of them, and then I move to the XYY's. Okay, I've got it now. So this is not correct. Now I'm going to go to the Y section. And I'm going to have a Y, and a YY, and I better stick with all the YY's. Here's a YY, here's another YY, triple Y, and quadruple Y. Both start with YY. Y. But just a second. I did it wrong again because I moved on to the YY's before I moved on to the YX's. So I'm going to start with the Y. Now I'm going to move to the YX's. Where are the YX's? The YX's are, there's 2 of them. There's a YXY and a YXXY. Which one comes first? The one with the X in the 3rd place comes before the one with the Y in the 3rd place. Y, X, X, Y comes before Y, X, Y. Right? Yeah, because let's finish it, and then I'll show you that we've got it right. And if we don't have it right, we'll fix it. Okay, you've got to check these things. Okay, so I've got 4 of them. Now I'm going to go to the YY and the YYY, and then the 4 Y's. And that's too many. I had 6 X's and I need 6 Y's. I've got 7 of them here. Oh, this one's not a palindrome. YX is not a palindrome. Get them out of here. Okay, now let's look at it. I stick with the prefix Y. Then I go to the next prefix, which is YX. Why do I go to YX before YY? Because X comes before Y. And I do all the YX's. Now, after I have yx, I have to add the x first, and then the y. And I've got all the yxx's, and I've got all the yxy's. Now I finally move to the yy's, and I've got 3 more of them. And now I've got, in dictionary order, all 12 of my palindromes. Okay? And so you see here that it's very easy to make one of 2 different types of mistakes, multiple different types of mistakes. Here I included one of the things that's not a palindrome. Here I got some of them out of order. Okay. Here I forgot to go to the yx's before I went to the yy's. Okay, so this is, I would say, absolutely typical and normal of any computer scientist putting these things in that order. Okay. Part B says all the strings or words that begin with X that have length less than 4, list them in dictionary and length versus lex. I guess I'm going to make a new video to do the last 2 parts, and I'll quit this video here.